Okay, today we're going to start our fourth unit, and it's basically part of circles. We've split circles into 2 units, and we're going to start with just talking about circles and angles in this unit. Today we're going to look at some basic circle vocabulary, and then the relationship between a central angle and what we call its intercepted arc. So a circle is a set of all points equidistant, which means the same distance, from a given point called the center. Okay, and when we name the circle, we say circle G. We use its center, which is right there. Okay, so its center is G, and we name it using the circle and then this symbol. Okay. A diameter is a segment that contains the center. So it also goes from the sides of the circle. And it's a segment, so we name it with the 2 endpoints. So RT would be a diameter. SU would be a diameter. And you could switch them around, of course. A radius is the segment with an endpoint on the center and another on a circle. So its relationship is half the diameter, which we talked about in class. So in this case, we could have GS, there's a whole bunch of them here. We could have GT, GU, QR, GR, looks like I missed one, GQ. Okay, and the G's don't necessarily have to come first, but when we are naming a diameter or a radius, you must have the segment bar above it because they're segments. A semicircle is half a circle. Now, let's talk about circles real quick. Circles have 360 degrees in it. So if I started at this point right here and went all the way around, it would be 360 degrees. A semicircle has 180 degrees. So this is a circle. Okay, it has 360 degrees. A semicircle is half a circle. And we name it using the endpoints. So we say arc SU, and we'll talk a little bit more about that. So a minor arc is an arc that is smaller than a semicircle. So minor arcs are less than 180 degrees. We name them with their endpoints. So RS would be this arc right here. Okay. If I wanted to go from here to here, okay, that would be arc QT, or you could also name it arc TQ. Those aren't different arcs, they're just arcs with their endpoints switched around. So there's lots of minor arcs on this circle. A major arc is an arc that's larger than a semicircle or more than 180 degrees. And to name a major arc, you must have 3 points. Okay? It's endpoints and a point in between. So if I'm going to name this arc right here, and we know it's greater than because its endpoints are on different sides of the semicircle, we could name it SQT with the arc symbol over it, or we could actually name it SRT. We could name it SQT. Notice that my endpoints are the same. Okay. So to distinguish, because we have two arcs with an endpoint at S and T, to determine which one we mean, we use the 3 points for a major arc and 2 points for a minor arc. Okay. Now, a central angle is an angle whose vertex is at the center. So here is the center of my circle, and here is my central angle, one of them. Okay, so that central angle would be angle RST or angle TSR. Now, the measure of what we call an intercepted arc. So if you can imagine that your angle, because it goes on and on and on forever and ever, is there, interception in football is you're stepping in, you're intercepting it, you're cutting something off. So this is your intercepted arc. Okay. RT. So the measure of angle RST is equal to the measure of arc RT. So we say those are equal. Notice I'm using the M to mean the measurements in both of those. Again, your notation is important. So we have an arc addition postulate, just like your segment addition and your angle addition. And it just says that the measure of arc formed by two adjacent arcs is the sum of the measure of the two arcs. So basically, if I have QR and RS, it's going to be equal to this whole thing. Okay, so the measure of arc QR plus the measure of arc RS equals the measure of QS. So now we can use a lot of these facts to find the measure of each of our indicated arcs. So GJ is right here. We've got the square there, so that's equal to 90 degrees. Okay. GJI, remember, is your major arc that is between here and here. So that's going to be 90 degrees plus 151 degrees, or 241 degrees. Okay. HGJ. Okay, notice that its endpoints are the semicircle, so this is 180 degrees. Okay. HGI is your semicircle plus this 151. So that's going to be 331 degrees. HI is just this little point right here, and we could figure that out a couple different ways. We know that HJI, the other one, is 331, so we could do 360 minus 331, which would give us 29 degrees, or because we know that this is a semicircle and this is 151, we could also do 180 minus 151, which would be 29 degrees. Either way works, you're getting the same answer. All right, so now we want to find the value for x. So I know my angle here is 11x minus 2. Its intercepted arc is 75. Sometimes it helps to use colored pencils so that you can actually see what you're doing, because you're going to get a lot of arcs in here. So we know that 11x minus 2 equals 75 degrees. Our intercepted arc is equal to the central angle. So 11x, if I add 2 to both sides, is equal to 77. And if I divide by 11, x is equal to 7. All right, so now, even though this angle measure is 101x, we know then our arc is 101x minus 1. The whole circle is 360 degrees, This is 110, so all of my arcs add up to 360 minus 110, or 250. If I add up all my other arcs, I get 101x minus 1, 54x plus 1, 46x minus 1, and 49x plus 1. That's going to give me 250x. My ones will all cancel out. -1 plus 1, -1 plus 1 equals 250. Sorry about that. So if I divide by 250, x will equal 1. So circles, remember, are named by their center. There are 360 degrees in a circle. Major arcs are more than 180 degrees and named by 3 points. The minor arcs are less than 180 degrees and named by 2 points. And the measure of an intercepted arc is equal to its central angle. So have a math-tastic day.